In this video, we're going to solve example 2 here, which is another example of the sine law. And we know it's the sine law because we're given two angles on one side. And right off the bat, we see we have an angle side pair, meaning we have angle A and side A, so we can use the sine law. We'll start by finding angle C, though, because it tends to be the easiest. So angle C is 180 degrees minus angle A and angle B, so 56.29 degrees minus 97.06 degrees, and that's simply because the sum of the angles of any triangle is 180, so that gives us 26.65 degrees. So there's angle C. Now we're going to use the side angle pair of A, meaning we're going to say the sine of A over the length of side A has to be equal to the sine of B over the length of side B. And solving for B then will let us find side B. So B is going to be A sine B when we cross multiply divided by the sine of A. So B is going to be A, which is 63.71, times the sine of B, which is 97.06, divided by the sine of A, which is 56.29 degrees. And we're going to stick that in our calculator and find that the answer is 76.01, which is greater than A because angle B is bigger than angle A. So it makes sense. To find C then, we're going to do the same thing, except now we're going to do it with sine C. So we have sine A over A is going to equal sine C over C. Solving again, we get C equal to A sine C over sine A. Substituting in our pieces, we get A, which is 63.71, multiplied by the sine, this time of 26.65 degrees, divided by the sine of A, which is 56.29 degrees. And that lets us know that C is equal to 34.35, which is smaller than A. It happens to be the smallest as well because C is the smallest angle. So there's our three answers: angle C, side B, and side C. We'll move on now to the next example. And in this example, we're going to talk about case 2, which is if we have two sides given and the angle opposite any one of them. Because the angle is opposite one of the sides, we know we have a side angle pair, which means we can use the sine law. However, we need to be careful here because we may end up with one solution like the questions before, but we can also possibly end up with two solutions or even no solutions. And it has to do with the fact that we're going to have to find an inverse sine, and we know that inverse sine can be positive in quadrant 1 and quadrant 2. And any angle from quadrant 1 or 2 can be possible in a triangle, so we have to check to see if we're going to have more than one solution. So we'll see if that makes more sense when we work through it here. So we start by sketching our diagram, angle B, side B, and side A. And because we're limited in space there, I've resketched it there in our top left corner now, and we'll work from here. So we need to find side C, and angle A. Since we know angle B and side B, we're going to start with the sine of B over B, and we're going to use that to find angle A because we know side A. So there's our first step. So we're going to solve that for sine of A, and that's going to be A sine B over B. Filling in the pieces now, we find that sine of A is going to equal A, which is 60, multiplied by the sine of B, which is 30, divided by B, which is 40, which gives us sine of A equal to 0.75. So we're looking for A, so we do sine inverse, and this is no different than anything else we've seen. But now we remember sine inverse gives always two possible answers depending on the quadrant and the sine. So this gives us A equals 48.6 degrees, and we know that's quadrant 1, the reference angle. But sine is positive in quadrant 1 and 2, So, or quadrant 2 would be 180 minus that, which is 131.4 degrees. So we have two angles to consider. If A is 48.6, then our triangle, these two angles, A and B, add up to 78.6, which is fine. If A is 131.4, then A and B add up to 161.4, which is also fine. So both angles are possible in our triangle. To continue then, we have to consider both situations. So first we're going to say when A is equal to 48.6 degrees, then we're going to get angle C as 180 degrees minus B, which is 30, minus 48.6 degrees. And find out then that angle C is going to be 101.4 degrees. And we also need to find side C. So sine B over B equals sine C over C. Cross multiply. We want to solve for C, so that's sine C multiplied by B over sine B. And I'll let you plug in the pieces on your own, but we end up with the answer 78.4 here. And so there's one set of answers. We have A is 48.6, C is 101.4, and side C 78.4. But we also have now when A is equal to 131.4 degrees. And if that's the case, then angle C is going to be 180 degrees minus 30 degrees minus 131.4 degrees, and this time angle C is going to give us 18.6 degrees. And we continue with sine B over B equals sine C over C to find side C, and the same formula, so we plug in the pieces. B is 40 sine of 18.6 this time over the sine of 30, and when we work that out, we find that C is going to be 25.5. And so that gives us three different values: 131.4 for angle A, 18.6 for angle C, and 25.5 for side C. And both are possible solutions. So either is correct. Or in this case, you actually need to find both. Both are correct. So just to check our answer, the largest angle in the yellow solutions is 101.4, and the largest side is 78.4, which makes sense. In the green, our largest angle is A, 131.4. Our largest side is A at 60. So that makes sense. And if you check the smallest in both, you also see that that's correct. So there's that solution, an ambiguous case where both triangles are possible, or there's two possible solutions. In the next video, we'll look at case number 3, which is our first look at the cosine law. Make sure you do some more practice. There's lots of examples in your notes that you can do. If you're having any problems, get some help as soon as you can, and we'll see you in the next lesson.